Yeah, students, now we will start unit number 5. Here there are two major topics in unit 5. One is isometric projection and the other one is orthographic projection. So from a given isometric view, we have to draw the orthographic views. So that is also known as freehand sketching or freehand drawing. So now first we will see isometric projection. So in this session we will see the introduction about isometric projection. In next session we will solve problems on isometric projection. So prior knowledge, you require this prior skill set. One is projections of simple solids. Already we have seen projections of simple solids and sections of solids. So sectioning is nothing but cutting the solid. When the solid is cut in some way, how that is projected in three-dimensional projection, that we are going to see here. Methods of projection: orthographic projection, isometric projection, oblique projection, perspective projection. So to introduce this three-dimensional projection, we have these many types of projection methods, and we have in our syllabus orthographic projection and isometric projection. And in brief, I can give you the introduction about the different types of three-dimensional projections. So here any graphical projection can be classified under two groups. One is parallel and another one is perspective. So this parallel projection is drawn with given dimension. In perspective projection, it is the actual view. It is also known as photographic view. So in photographic, we can see the front edges will be with bigger size, and when you see the edges which are behind and which are a little away, they will be looking like smaller edges. So like this. So this is the bigger edge compared to this edge. Even though both are having the same dimension, this looks like a smaller one and this looks a bigger line. So this is perspective projection. It is known as the actual projection. So in a real view we can see in this manner only, whereas in parallel projection, whatever dimension is given and whatever dimension we have, with that we used to project. So again, this parallel projection is classified into two groups. One is orthographic projection and another one is oblique projection. So in orthographic projection, in first, this is the primary, this is multi-view projection. So to give the details of any object, we require three views, minimum number of views required to describe any object, that is three views. So this is front view and top view, this is the right side view, and this way we can give the description of any object to others. Whereas in isometric, instead of having three views, we can give one three-dimensional projection, one three-dimensional view, that is known as isometric projection. So this is isometric. Under auxiliary method, the first one is isometric, this is dimetric, and this is trimetric, and we are going to discuss only isometric projection here. And this is the first angle projection. So in this is the third angle projection, and plan and elevation are drawn separately. So these are the methods in multi-view projection. So the first angle projection we have used all along, whereas here I am introducing the three-dimensional projection under isometric concept. So isometric projection, it is a method of producing pictorial view of an object showing all three faces of the object simultaneously on a single reference plane. So this is isometric projection, simple definition. It is a type of parallel projection. The angles between any two of the three coordinate axes is 120 degrees. This I will show you in next slide. the actual true sizes can be measured directly from isometric view. So here whatever true dimension is given, whatever dimension is given in the view, that can be measured and that can be used as it is. So isometric view is actually drawn with the true dimensions only. 3D drawings in different ways. So this is one three-dimensional view, and this is another three-dimensional view. So the purpose of isometric drawing is to understand overall shape, size and appearance of an object prior to its production. So first, instead of giving three views like in orthographic projection, we are using a single view. With that we can give the complete details to the customer or to the layman or to our client. So ISO condition, so this is the isometric condition. So these are the three axes, these are known as three axes, and the angle between any two axes is 120 degrees. So this is the isometric view, and this is the isometric view of cube. Isometric terminology, the three coordinate axes are called isometric axis. Any line parallel to isometric axis is called isometric line. A non-isometric line is a line not parallel to any one of the three isometric axes. So we have seen isometric axis. Actually, a line which is not parallel to any one of those three axes is known as non-isometric line. And in isometric projection, of cube, the faces of the cube and any plane parallel to them is called isometric planes. So I will show you the isometric planes. The principle of isometric projection, this is the actual cube, and this is the actual the shape of the cube, and this is the true shape of the cube, and it is a square, and this is drawn at 45 degrees to the diagonal. So that is the actual square, and whereas iso square is drawn at 30 degrees. So at 30 degrees, now this cube is arrived where the diagonal of the cube is kept perfectly perpendicular to ground. So in that way, if you keep the cube, you will get this shape, whereas these three lines which are invisible edges will meet at the center, right, to the visible three edges. So that is the isometric concept. So this is the axis can be defined, or axis can be arrived from this concept, where the diagonal of the cube is kept perpendicular to ground. So in that fashion, if you keep, right, you will observe this view. So this is the view. It will look like a hexagon. Now this is isometric line, and this is the actual line. So now this is the triangle. These are the two identical triangles are formed here. With those two identical triangles, right, or we can define this, right, in triangle MQO, right, this is MQO, QM by QO equal to 1 by cos 45, it is equal to root 2. In triangle another PQO, another triangle PQO. So this is MQO is actually the actual triangle, and this is the iso triangle. So this is PQO is iso triangle. So here if you take the ratio QP by QO, identical sides, and it is cos 30, it is 2 by root 3, and the QP by QM can be obtained. So QO is common for both triangles, and I can get the ratio between the iso side and the actual side. So this is the QM is the iso side, QM is the true line, and QP is the iso line. So I can get the ratio between QP by QM, so that is equal to 0.82. So whatever dimension we have in real, so that should be converted to or multiplied to this value. With this value we will get the isometric length. So this length is used to draw the isometric projection. So in case if the question is given like this, draw the isometric view. So in this case, no need to convert it to with the 0.82. So to get the isometric concept, I have given this. So isoplanes, there are two planes. One is iso 30-30 plane. So this iso 30-30 plane is also known as iso horizontal plane. So this is iso horizontal plane. So at 30 degrees draw this line, and another 30 degrees you draw this line, and draw a parallel line to this line from here, and draw a line parallel to this line here. You will get a plane. So this is the plane known as iso horizontal plane or iso 30-30 plane. Next one is iso 30-90 plane. So this is known as iso vertical plane, and here as usual we take this, and this is 30 degrees, and one line should be drawn at 90 degrees. So here this line is at 90 degrees and this line is at 30 degrees, and now this is known as iso 30-90 plane. So here this is the axis, this is another plane which is also called as iso vertical plane. So construction of isoscale. So this is how you should construct isoscale. So especially this scale is used when you get question to draw isometric projection. Otherwise, no need to use this scale. So this is AB line. So this is the ISO 30 line. So this is 30 degree line. Draw a line at 30 degrees, and now this is you can name it as AC line, and another line you draw at 45 degrees, right? This is 45 degrees line, and now this is true length line, and this is ISO length line. So this is ISO length and this is true length. So whatever dimension is given, right, whatever dimension is given, so that should be marked here, right? That should be marked here, and you should draw a vertical line till it meets AC line, right? If you drop down a vertical line up to AC line, and this length if you measure, that will be your ISO length. So instead of multiplying with the 0.82 each and every time, you can directly measure on ISO scale like this. If you measure here, this gives you graphical solution. So it is equal to the value that you obtain when you multiply with 0.82. So this is one for one length. Another length should be marked here, and from there you can drop down and you can measure, and whatever lengths those are given in the problem except angle, every dimension should be converted to ISO length in case only when you have to draw the isometric projection. Suppose in the question if it is given as isometric view, there is no need to convert it, you can use as it is. So this is the isometric scale. So this is how you should construct, and you should measure an isometric length and measure here and use that. So this is one way. There is another way to draw isometric scale. So I am not using that, and you can use this method. This is simple method than the another method which is available, and you can use this, and this is the actual diagram, three-dimensional diagram. So this is known as isometric view, and you can convert, once you convert this to isometric projection, so this will be your the isometric projection, and which is smaller than this view. So because you are reducing to that value, right, you are multiplying with lesser than 1, and that value is 0.82. So once you multiply with 0.82, you will be getting a reduced view like this. So isometric length equal to 0.82 into true length. So this is the mathematical relation. So instead of this, you can use this scale, so that saves you time also. So types of isometric drawings, so they are isometric view and isometric projection, and here this is isometric view and this is isometric projection. It is reduced dimensions. And difference between isometric view and isometric projection is isometric drawing and isometric view is one and the same. and no need to multiply. Suppose if you are getting question isometric drawing, there also no need to multiply with 0.82. In case of isometric view, no need to multiply with 0.82. Only in case of isometric projection, you have to multiply the given dimension with 0.82. So instead of multiplying this, use isometric scale. So dimensioning, actually dimensioning we are not going to do, but this is the correct way to represent dimensions. And whatever dimension line you draw, so that should be parallel to the isometric axis. So that is here also parallel to isometric axis, whereas here this is inside, right? So try to do the dimensioning inside the diagram, whereas here these are not at all parallel to isometric axis, so this is not correct. So dimensioning is same as in orthographic projection, but dimensioning line should be parallel to isometric lines. So this constraint you have to follow everywhere. So isometric of plane figures, so this is the shape, and front view, top view, and rectangle. So this is the rectangle. For this rectangle, top view is drawn on 30-30 plane. Sorry, front view is drawn on 30-90 plane. So this is the 30-90 plane, and whatever dimension, so the B is taken as my reference point. From here I have drawn the rectangle in front view. So this is the front view, and B2C, measure B2C along this line, L line. You measure B and C and draw thick line, and AB, whatever dimension you have, draw AB line, and then AD line is parallel to BC, and DC line is parallel to AB, and you can complete it on 30-90 plane, whereas top view should be drawn on 30-30 plane, right? So this is 30-30 plane, and triangle also same way. So take this 2 as a reference point. So in front view use 30-90 plane, right? 30-90 plane, and draw thick line. So thick line, this is 1 2, and 3 is the midpoint of BA line, so mark 3 here, right? And then draw the triangle, this is vertical triangle, front view, and horizontal triangle on 30-30 plane. So on 30-30 plane it can be completed. And isometric, same thing, shape is pentagon. So pentagon is draw the pentagon and enclose that pentagon within this rectangle. So 1 2 3 4 is the rectangle, 2 as reference point. So on 2, right, and draw that rectangle. So if you complete rectangle, on that you can mark A B C D E easily. You can measure 2 towards 1, measure 2A distance and mark on the same line 2 towards 1, right, and A, and then 2 towards 3 mark B, 2 towards 3 mark C, and midpoint of 1 4 line will give you point E, and A parallel line if you draw here, right, you will get D. So no need to measure A again, D again. So this gives you pentagon, which is vertical, and the horizontal pentagon should be drawn on 30-30 plane. So in same way, right, same way. So hexagon is also same way. So enclose the hexagon within bracket, within rectangle, and then use 30-90 plane for vertical hexagon, and use 30-30 plane for horizontal hexagon. So isometric shape is circle. So this is circle, and to draw circle there are actually two methods. I will come to those two methods in coming slides. So this is front view and this is top view, right? Obviously it is an ellipse. Semicircle is drawn like this, right? So semicircle also can be drawn using those two methods. So points method, to draw circle, this is the points method. So here enclose the circle within a box, right? So now you can divide this into 8 equal parts, right? So 1 2 3 4 5 6 7 8. So totally you are getting 8 points. So you can draw, this is vertical, right? So those points can be marked, 1 4 2 3 can be marked on the square itself. And to mark 8, right, 8 7 6 5, you have to do this small exercise. S towards R, measure SM distance, right, and mark here. Once you mark, you can mark from R, you can mark from Q, and you can mark from P, and on both sides. Obviously SM distance is equal to SN distance, and same distance can be used here also. And for all the corners you can repeat the same procedure, and you can get these points 5 6 7 8. So 1 2 3 4 is on sides, so midpoints you can directly mark. So you can connect them using French curves, very fine curves you can draw, and you can get this ellipse. So this is the drawback. So if you are not knowing how to use French curve, then you will be in trouble to draw this. With free hand only you have to draw this. So in that case you may not get the correct shape, right? So that is the disadvantage with this method. And this is the 30 90. So this is another vertical circle, this is horizontal circle. In same procedure you can follow here, and you can mark 1 2 3 4 5 6 7 8 points, and you can get the horizontal circle. So that is the disadvantage here. So instead of using points method, there is another beautiful method and very easy method where you can use the compass to draw this ellipse. So that is the 4 center method. So here the 4 center method is another method which is very convenient, where you can use compass to draw this ellipse. So this is, I will teach you how to draw using 4 center method, how to draw the circle using 4 center method. So first, given circle, as usual, enclose this within a square, and this is 30 30 plane, right? So this square dimension you measure and draw the square, iso square here. So this is iso square. So now it is very simple using this method. Identify the smallest diagonal. So this is one diagonal, this is one diagonal, and this is another diagonal, right? So this is the longest diagonal and this is the shortest diagonal. Identify the shortest diagonal, and now you can make use of these two as two centers, right? As name suggests, there are four centers. So 4 centers we can obtain here like this. First, identify the opposite corner, right, for smaller diagonal, right? So now mark 4 centers, 4 center points of each side. So mark the center point for each side, and these are the 4 center points. Now these are the sides. Now with this center point, opposite corner, right, opposite corner of that smallest diagonal should be connected, right? From each center point to the opposite corner should be connected. So for this point, for this point, for these 2 points, this is the opposite corner. Again for these 2 points, this will become the opposite corner, right? So now you connect them like this, right? So this is connected and this is connected, and from here you connect here, and from here you connect here, right? So now I have obtained all 4 centers. This is one center, this is the second center, another center, and fourth center. So these are the 4 centers I can make use to draw my circle, right? Now this procedure is very simple. Now take this point as center, and this point to A, this much as radius, right? This much as radius, and obviously that will be same as this radius. Now from here to here you can draw an arc, right? You can draw an arc, and now this is the center, right? So this is 1 2 3 4. Now these are my 4 centers, right? Now this as center, this much as radius, 1a as radius. Draw the arc between A and B points, right? So this much as radius. So obviously 1a is equal to 1b, and this is the arc that can be drawn using compass, right? So from here 4b as radius, 4b as radius, right? And 4b as radius, point number 4 as center. Draw the arc between C and B, right? now same as here. Now take this as center, 2D as radius, 2 as center, draw the arc between C and D, right? So now 3 as center, draw the arc between D and A. So how easily you can draw this, right? So this gives you a perfect ellipse, whereas and also curve will be very smooth since you are using compass. So this is your horizontal circle, right? Horizontal circle, and this is vertical circle. This is vertical circle, same procedure. So this is the smallest diagonal and this is the longest diagonal, right? So this small diagonal should be used as two centers, and now same procedure you repeat here, and you will get the circle, isocircle. So that is obviously an ellipse, right? So this is the vertical circle, and this is the horizontal circle. So this is the four center method, and I suggest and I prefer this method to be used everywhere it is usable or it is applicable. So please practice this four center method well. So isometric view of a pentagonal pyramid standing on HP, right? So this is the pentagonal pyramid standing on HP. So this is the pentagon, and now you can get it center. So from center with the given height, right? So this is a pentagon, and this is the pentagonal pyramid which is standing with the given height from this center point, right? From this center point you can draw the height, and that is the axis line. So this is the axis line, and from every corner you can connect it, right? So this is isometric view of the pentagonal pyramid which is actually standing, right? And the isometric view of the figure shown with the dimensions, right? And this is the figure, and this should be drawn in both vertical as well as horizontal. And this is the top view, right? Top view is horizontal. It should be, you have to use 30 plane, right? So draw a line at 30 degrees, draw an infinite line, right? Because the 50 mm is given, or you can draw a 50 mm thin line, right? And 100 mm thin line on another 30 line, right? This is 30 degree line, so another 30 degree line, so that is 100 mm, and here it is 50 mm, right? So complete the box. So this is the iso rectangle here. So this is the iso rectangle you are drawing here. So now you can use the four center concept to draw this curve, right? This is the curve. You can use a four center concept. Now I am dividing this into two parts, right? I am dividing this into two parts, and now this is my diagonal, smallest diagonal, and I have used these two, right? This is only half four center I am using, right? So this is the center now, right? Now this much as radius, you can draw the arc, right? You can draw the arc. So this arc is obtained here like this, and now from this is the center, right? This is the smallest diagonal, and this center is used to draw these two lines. Now this much as radius, right? This much as radius, from here to here, draw this arc, right? Draw this arc, and then you connect them, and this will be your horizontal object. So the given object is drawn horizontally here, right? So the vertical front view should be drawn in same manner, but it should be drawn on 30-90 plane. So this is 90 plane and this is 30 plane. So on 90 line you measure 50 mm, on 30 degree line you measure 100 mm. So now you draw the rectangle here, draw the rectangle as usual, and then divide this into two parts, right? and now this is the smallest, this is the corner which is compressed, right? So now you can use 4 centers, right? This is the smallest diagonal, right? So this is here we will start. So this is the smallest diagonal, right? And this is the longest arc, right? So this should be used as center, and this much as radius. Draw the arc between those two center lines, center points, right? Similarly here you can draw, you can connect them with iso, right? This is iso center you are getting here, and this should be taken as radius, and draw the arc, draw the arc. Now connect them, and you will get the standing, that is the front view of this object, right? So anything, right? So it is like we have seen geometrical construction in case of orthographic projections. So here also it is used, this is known as the geometrical construction is in isometric projection, and it is very simple, and you should apply this these two planes effectively, 30-30 plane and 30-90 plane. And this is the pentagonal pyramid, right? Pentagonal pyramid lying on HP, right? It is the 30-30 plane, right, is used to draw the front view, and that is the true shape of the pentagon. And now this is prism, right? From each and every corner parallel to 30-degree line, you draw the given height. Now it should be drawn, and this should be connected, and this is your hexagonal prism, right? Hexagonal prism. And this is the standing prism, right? So here you have to use 30-30 plane, right? On 30-30 plane draw the hexagon, right? And from each and every corner draw the thick lines, right, which are visible. Obviously we are doing solid modeling, invisible edges can be ignored here in isometric projection. And this should be connected like this, and now you obtain a standing prism. It is a standing prism. Cylinder lying on HP, so it is very simple, you can use 4 center method, and this is the cylinder. Now this is the cylinder, this is front side and back side, and draw the edges, draw the edge, which is the tangent should be drawn, right, from both circles, and this part is not visible, and that can be removed, right, that can be removed. So this is the sleeping cylinder, and the standing cylinder should be drawn on 30-30 plane, right? So this is the cylinder which is standing, right? Now draw the tangents here, right? Those will become the outermost generators, and this should be removed, and this gives you the standing cylinder. And half cylinder can be drawn, so this also can be drawn using 4 center method, and this is the half cylinder, right? Half cylinder, and same view should be drawn here, right? And draw the tangent here and here, right? And this should be removed, right? This should be removed, right? So this is the 2 edges, and this is the tangent, right? So this gives you the half cylinder, and standing half cylinder is same, right? You can draw and you can remove the invisible edges, and this is the standing half cylinder. So to draw the half semicircle, you can use 4 center method. So here a square pyramid of 30 mm base sides and 50 mm long axis is centrally placed on the top of a cube of 50 mm long edges. Draw isometric view of the pair, right? So here isometric view only, no need to draw anything. So this is the cylinder prism, right? Prism. So it is a cube, right? Cube is a type of prism, and use the centers effectively, and from here draw the height, given height of the pyramid. Now connect them, right? This is the combination of solid, simple solid, and you can draw the invisible edges only with thick lines. So it is this pyramid is centrally placed, and from this center point, you can measure the height, and you can mark the remaining corners. It is a square cube and square pyramid, and this is a cube, right? So this is how you can draw the combination of solids also. Draw the isometric view of a cylinder resting on one of its ends on HP, right? So it is one face is resting on HP, right? For this you have to draw the isometric view. So draw 30-30 plane. So it is a cylinder, and this is very simple. I use 4 center methods, right? 4 center method. You can draw the top. Always start with top, because invisible edges always remain in bottom surface, so those invisible edges can be avoided, right? So now draw the top surface first. Always this should be your practice. Now draw the half circle using same 4 center method, right? So half circle using 4 center method. So now this should be drawn using that 4 center method. So this is the resting on its face, right? And you can draw the vertical cylinder, sleeping cylinder also, right? Like this. Sleeping cylinder should be drawn like this, and this is the visible face, and this is invisible. The little part of the this base is goes invisible, and so you complete it first here, and then later you can draw the remaining portion here, right? Using 4 centers you can draw like this, right? So this is the sleeping cylinder. This is the sleeping cylinder. And draw the isometric view of a hexagonal pyramid of base side 15 mm and height 55 mm, resting on its base on the HP with the two sides of the base parallel to the VP, right? So now the orientation is given, two sides are parallel to VP, and note that you are going to draw only isometric view, so no need to use isometric scale, right? Directly you can use the whatever dimension is given in this problem statement, so that can be used. So draw the hexagonal pyramid, right? Hexagonal pyramid of 15 mm side, right? So this is the hexagonal pyramid. Now these two, right, these two sides are parallel to VP, so that is the condition given. Two of its base sides are parallel to VP, so you have to draw the orientation only in this way, right? So now hexagon should be enclosed within box, so I have marked O, that is the actual apex, right, and O1 for my reference, right? So it can be avoided, right? Even if you are clear, no need to mention O1 at all. So I am drawing this rectangle. So 1 2 3 4, always 1 I am using as reference. So I am drawing the simple front view with 55 mm height, right? So this should be drawn on my space, right, on my horizontal plane. So I have to draw 30-30 plane to make it stand, right? So this pyramid is standing pyramid, so 30-30 plane I am using, right? So I can make the sleeping pyramid also. I will show you that, right? So now this is 1 2 3 4. So I am marking A B C D on this rectangle, iso rectangle A B C D, right? And mark the center, so that is my O1. This is O1, right? Mark the center, it is O1. So it is very simple. Mark the center point of 1 and 2, so that is my M, and from M to here you measure this distance and mark here, so that gives me O1. So this is my O1. From O1 55 mm you draw the axis, right? So outermost points, right, should be connected to apex first. So outermost point is C, I am connecting to O, and B is visible, BO is visible, I am drawing a thick line, and AO is visible, I am drawing a thick line, and OF is also visible, I am drawing a thick line, right? O is here. So E and D are invisible points, so I can leave them as it is, right? No need to connect them, right? No need to connect them. So anyhow I am just erasing them, right, to give you clear picture. right? But you can leave as it is, no need to erase them. So this is the isometric view of this pyramid, standing pyramid. So this is the sleeping pyramid now, right? Sleeping pyramid. So from O1, so same way, right? So this is the 30-degree line, 30-degree line. On 30-degree line, you have to draw this axis line. So once you get this height, you can complete it in same way, right? Same way. So AO is not required to connect, BO is also not required to connect. So that gives me the sleeping pyramid, right? Draw the isometric view of a right circular cone of base diameter 34 mm and height 60 mm when it is resting on its base on the HP, and also draw isometric view of the cone in horizontal position, right? So this is the cone. Use 4 center method and it is simple, right? You can use 4 centers, and from center you draw the height and mark O, right? And only draw the semicircle here and connect it. This gives you the standing cone, right? And now this is the sleeping cone, and from here, from center, draw 30-degree line, right? So this should be 30-degree line, 30-degree line, and mark the height here, right? This gives me the cylinder, right? Sorry, cone, right? Cone, sleeping cone. So there ends the introduction part of isometric projection, and you can refer the this book, right? This gives you more information, and in next session we will try to solve more number of problems, right? That includes section plane also. That gives you very good insight in this topic. Thank you.